Hello viewers, welcome to Big Boy Physics. In today's video, I'll be discussing a problem from kinematics and I have picked up this from European Physics Olympiad. So this question involves a little bit of mathematics and vectors. But don't worry, I'll be covering it all of them in this video. So let us read the problem first. The problem says that a massless thread makes end turns around a statically fixed cylinder as shown in the figure. Initially, the free or the unwound ends of the thread are parallel to the x-axis. Then a heavy point-like object P is attached to one end of the thread while the other end is pulled with the constant velocity u along the x-axis. The question is to find the maximum velocity attained by the heavy object. It's also given that the thread is inextensible and flexible, and suppose that the turns on the thread are wound tightly on one to other and are placed practically in the same plane, perpendicular to the axis of the cylinder. Neglect any friction and do not consider any force of gravity. Okay. So what is the first thing will come out to our mind is about writing the force equations and all those. And what is the mass of the block? Well, the mass of the body or the ball is actually not required in this question. So yeah, let me present you the solution. Rather, before that, let us first draw few shapes. That is a circle. We need a circle for this question. Uh, yeah, just a minute. Yeah. So we need to make a cylinder or a circle, or that is the cross section of the cylinder is a circle for this understanding the dynamics of this question. Suppose this is the circle and a thread is there which I am pulling. Here's a thread I am pulling with velocity u and that is constant as mentioned in the question. So this thread which I am pulling is wound to the cylinder and I am pulling it at a constant rate. And similarly, I have a heavy ball attached to other end of the string. Suppose the ball has mass capital M, and as we proceed to the question, we'll be observing that capital M is basically an unnecessary variable which I introduced in the first. Okay. So yeah, another variable which we need in this problem is that suppose when the mass reaches some other point, suppose initially it was at P and now it reached P prime. The point of contact of the thread with the cylinder makes an angle phi. This phi variable is very important in this question, and I represent that d phi by dt is given as phi dot. Okay. Now when it reaches such kind of position, it will have two velocity components. So let me mark the velocity components. One would be perpendicular to this, that is v perpendicular. Other would be parallel, that is v parallel. And I introduce two unit vectors. Suppose this is e1 vector and this is e2 vector. So I can say that velocity will be given as v parallel e1 vector plus v perpendicular e2 vector. Now, basic resistance of constrained motion says that the velocity of any object along this inextensible thread will be always equal to the along the inextensible thread. If you consider the 2 points, their velocity relative to each other in the radial direction will always cancel out. That is that the string is inextensible, so v parallel will come out to be minus u. Hence, I can say that velocity will be coming out to be minus u e1 cap plus v perpendicular e2 cap. Now, another vector which I introduced is outside the plane, that is e3 cap, and e3 vector is denoted by e1 cross e2. Okay, so e1 cross e2 will basically give me another unit vector, that is e3. Hence, I can say that the angular velocity omega vector that is of this contact point. Suppose the contact point I denote as q. The contact point's angular velocity will come out to be phi dot e3 cap, which will come out to be phi dot e1 cross e2. Hence, now if I try to differentiate this, we know that dv by dt will basically give me my acceleration. I'm just writing the vector notation. So dv by dt will be giving my acceleration, which I'll get it to be minus du by dt of e1 cap minus u times of d of e1 by dt plus dv perpendicular by dt of e2 cap plus v perpendicular de2 cap by dt. Now this is the differentiation of vectors. Okay, unlike scalars, you have to deal with this vector only. Now, if you remember that for change in the direction, we now e1 cap, e2 cap, all these have fixed magnitudes, that is 1. So if there is any change, all the changes will be in the direction. So d of the derivative of e1 vector or e1 cap is given as omega cross e1 cap, which will come out to be phi dot e1 cross e2 cross e1. Now, one thing you must know about cross products, that is cross product equation, that or the triple vector product, which is called the VTP, vector triple product, that is A cross B cross C is equals to A dot C B vector minus B dot C A vector. So using the same concept, I'll get it to be phi dot E2 cap. Hence dE1 by dt will be coming out to be phi dot E2 cap. Similarly, you can derive that dE2 by dt will come out to be phi dot E1 cap with a negative sign. Okay. So yeah, hope you get it. Now coming back to problem, du by dt will come out to be 0. Now this term will be coming out to be minus u phi dot E2 plus dv perpendicular by dt E2 plus v perpendicular into minus phi dot e1 vector. Now observe that the acceleration of the body in the direction, that is e2 vector, or we can say rather that which is dv vector by dt dot e2 cap, will be acceleration of this body along the perpendicular direction to the string, and since the force along the perpendicular to string is 0, so it should come out to be 0. Hence this component will be coming out to be 0. Hence I'll get dv perpendicular by dt is equal to u d phi by dt, and from here proceeding the calculation you'll get just integrated v perpendicular is equal to u phi plus c. Now when phi is equal to 0, we know that v perpendicular is equal to 0. Hence v perpendicular will come out to be u phi. Now what happens is that when all the rotations are completed, so you get phi to be 2 pi capital N. Hence I'll get v perpendicular will be coming out to be 2 pi capital N into u. Now what happens is that the situation will be coming out something like this. Suppose this is the cross section of the cylinder, and now what happens is that my string will be just touching the cylinder and going tangentially. I am pulling this end with velocity u. By constraint motion, this bob or the ball should move with velocity u, and one velocity will be there which is perpendicular to the thread, that is v perpendicular. So at this instant, what will be the velocity of the body? Velocity of body will come out to be simply under root v perpendicular square plus u square, which will get u under root 1 plus 4 pi square n square. Okay, so this is the velocity after 4 thread winds. But wait, we are not complete here. They're asking the maximum velocity. Okay, now consider this point, that is the pulling point, that is the other end of this string, to be O. Now with respect to O, let us draw our observation with respect to O. Now with respect to O, what happens is that this bob is just having a perpendicular velocity, that is 2 pi n u. Now what will be the final situation, since there is no other external force, and if we sit in the frame of reference of O and move with a velocity u, clearly it's an inertial frame, so there is no question of pseudo force also. This implies that when the string becomes perpendicular, then it will have some velocity 2 pi n u, and it's moving with respect to that point O. Now, using the concept of relative motions, just add a velocity u to O and a velocity u to the body at that point. So you'll get V max is equals to u times of 1 plus 2 pi n. And that's the final answer. So yeah, it was indeed an interesting question, just not because of its concepts, because of its calculations. It involved vector triple product concepts rather. So yeah, I really rate this problem as a nice problem. So hope you enjoyed this video. Thank you. Have a nice day.